questions going on around here? Anything? It is.
Very hard.
It's kind of skill sets right now with this thing, right? Line ball and drawing, it's kind of skill sets. I don't expect you to memorize the functional groups. You have that sheet, so yeah, you should just know how to use the sheet, right? That's the main thing. Some of those you'll learn because you keep talking about them before long, you'll be like, okay. I've seen alcohols and carboxylic acids a million times, I know what they are.
Okay.
Today we'll start working on naming a little bit so you can get the structure of the name. That way when you see names, you just generically know what they're doing. All right? So you'll understand how that system happens, and out of that you'll be able to name things.
I guess I do have a question. On the, how would we count the number of carbons when it's a double bond? Because I know we did all those with the straight ones. But
Yeah.
when it has
So,
another line.
let me see if I can reword what you're saying.
Sure.
If you have something that has a carbonyl group in it,
Yeah.
do you count that carbon? Is that what you're asking?
Yeah, I'm trying to remember what the homework was asking, but it was giving us something like that, and then
Let's just say you have that,
yeah.
and you know that that is part of this group. You do count that carbon. So that's 1, 2, 3, 4 carbons.
Okay.
Then just be careful of, to me, that optically until you get used to them. Here, I'll do it this way. Here, maybe this is more the thing that you would see. This is a common thing that gets written in like there. There you go. And you might get a little thrown off and go, is there a carbon there? And it's like, no, that's the carbon that's connecting to an oxygen.
If we added another line to the one connecting to the OH, another, yeah, no, and then double it.
Oh, like this?
Yes.
Yeah,
Then-
that's a carbonyl. That's back to there.
So it's still 3 carbons for that.
Yeah. So now I go 1, 2, 3 carbons, and then the other thing is because it's carbon, I don't always assume H's are present. I mean, I do assume, right? So I go 1, 2, 3. Oh, there's actually an H assumed. So that's actually an alkyd. Probably the sneakiest way to write an alkyd. This is very obvious, right? But sometimes that's assumed in there. That's the fine details. So yeah, that part I'm glad you asked about. It's kind of a little sneaky till you get used to it. Well, shall we do it? Okay, we're going to dive into this. We're going to start with so again, we're going to basically talk about the hydrocarbon, which is the backbone, but we are going to expand up and kind of teach you the naming on it. And then out of that, it's easier to name the functional groups because they're all based on the backbone. Okay? So starting off, we're going to do the Alkane family, which is the ones that are all single bonded. Okay? And this is, just to put it in your perspective, this is your world of fuels. That I can't think of a single vehicle, whatever, right now that's not moving around because of an alkane. Because even like electrical cars, if you go back to the source, they're some sort of coal-fired power plant or something. They're basically straight hydrocarbons that are making this thing happen. You with me? All right. So with that in mind, I'm going to teach you how to name in organic chemistry. So the keys are that system I showed you on the board the other day. So you might want to have that out, so you're very confident with meth, eth, pro, but. That thing, so you might want to get that handy. And even if it helps, you might even write it along the side of this thing, and then it's always there if you want to. Shall we get it up? It's good practice. Starting with 1, what's the prefix? Math?
1.
2 is F. 3 is Pro. 4 is But. 5,
Pent.
6.
Hex.
There we go.
Hept.
Hept,
Oct.
oct,
Non. And des.
easy. There you go. So if you get that down, that's going to be key to doing the naming. And that'll help you with a lot of things. I mean, that's just kind of pentagons and hexagons. You're like, oh, okay, that's 5-sided, 6-sided. That, or you'll hear words like, oh, he's a heptathlete. What does that mean? Well, 7 sporting events. I mean, this sort of stuff is used a lot, so it's not a bad thing. So what they're saying is, the parent is going to be how we name in organic chemistry. It's the longest carbon chain. I go and find the longest carbon. That is going to be the parent. And with that, I'm going to also put on some prefixes where things are branching off the parent. And then a lot of times on the suffix, it's going to give us some details about the functional group. So that's kind of the format of how you name in organic chemistry. There's parent. I mean, the key is green. It's the parent. Find the parent. That's what I always tell people. If you're trying to name something organically, go find the longest chain. Okay? So, if I saw this, I would immediately go, what's the longest continuous chain I can get out of here? And you would go 4, that's but. So there's some sort of butane as part of, BUT is part of this name. I see this, I go 1, 2, 3, prop is something, part of that name. Okay? Now if there are branches off of here, that's what the prefix is about. That goes off and does something else. Functional group or another branch, then I would name it that way. And you'll see that here in a minute. That's the prefix. All right, so 4 carbons by tracking, 1, 2, 3, 4. So but is part of it, and then what family is the straight carbon chain, so we call it butane. So that's butane. That's the stuff that's in the lighter. See how the naming is? No branches, so there's no prefix to it. There's nothing else branching off of it. Now, let's talk about branches for a second. Usually, as far as alkanes go, like just straight carbons, there could be branchings of. So what we do is we try and go. At some point, the branch, right? That's a branch. But at some point, when I branch enough, all of a sudden it becomes the big parent chain. See how that switched? But because the branch is so big, it now takes over. And, oh, here's the new longest chain. Now the name just changed. And this is the branch. So with that in mind, you really only need to know branches of up to like 3 carbons. At the most, I'm going to show you 4. But again, I will give this kind of that chart to you, but very straightforward. The branches are named 1 carbon meth, 2 carbons eth, 3 carbons prop. So the branches could be a chain of 3 carbons. That would be a prop. So here you go. These are the very common ones, so methyl and methyl. And now, if it's a branch, they usually just put a YL on it. So you'll see it here in a minute. So here's all the branches. This will be a chart I give you, but just so you know how to read it. Very simple. 1 carbon methyl. That's a branch coming off of there. So this has a methyl branch. See it? Here's the parent. Find the longest carbon. Here's a branch that's a methyl. Got it? Ethyl is 2 carbons. Propyl is 3. Now, you could do 3 a little different though. I could connect to the middle carbon instead of the end carbon. So that gets a unique name. They call it isopropyl. Still 3 carbons in the branch. It's just connected in the middle. Now 4, you can imagine, you can start getting all sorts of variations. You can connect on the end, it's butyl. Is everybody with me there? Butyl, that's straightforward, 4 carbons, it connects off the end, butyl. Is that okay? Now you can imagine, well, what if I connected there? That's sec-butyl. That is no different than connecting here. Does everybody understand that? So I brought my molecules in today because things on the board aren't always as clear as when you really see them. So I'm going to just do a sec-butyl connection. There you go. So there's my butyl, right? And I'm going to, that's a branch coming off of something. So here's a sec-butyl connection. Do you see it? It's off the second carbon. That's, you go, well, that's different. Not really. If I just do that, that's, you see, it's the same thing. And these rotate in space. We've already talked about that. Single bonds rotate. So that's, so it gets easy when you realize that and you just go, okay, that's it. That's my in and there. That's my 2 connections off a straight chain. But I could kind of mess with it like this and go, oh yeah, but what about that? Now it's still a butyl group, but it's kind of different, right? Or what about connecting like this? That's kind of what this is looking at. This is called the isobutyl. And then if I did this and connected from here, that's called a T-butyl. It's like a chicken foot. But the nice thing about that is this chart will be given to you. So if you see a group hanging off of there, and this hasn't made the chain longer, so you know this is a big honking chain, that if this is hanging off of it, it doesn't make the chain longer, right? Maybe it's a 10 carbon or 12 carbon, and this is hanging out in the middle, so now it's a branch off of it. You'll have this in front of you, okay? But don't get nightmares over this. Are you with me? That's like, you know, the one once in a while homework question. This is not a common occurrence. Okay? But we do know, though, when we go to the, you know, time to get a little alcohol down at the, like for antiseptics and whatnot, you might have heard of isopropanol. Right? So now all of a sudden we go, oh, now I know. What does that prop tell you? How many carbons? 3. And it's not connected on the end, or it would just be called propanol. But when it's called isopropanol, it just means the alcohol group is connected in the middle. So now all of a sudden, now that you catch these words, you can start to use them a little bit. All right. So that's branches. Keep that in mind. This is about as high up as you go. There are other things for 5 groups, which is ridiculous. You don't need them. Because we're not going to do structures that a branch of 5, you're way, you know, if you're at 10 and you put a branch of 5, you just made the chain longer, right? So that's only relevant to things that are like 20 and 30 carbons long. All right. Just a reminder, we're lazy, right? The chains themselves sometimes get an R on there. Everybody's got that. R prime, R double prime is just trying to say something different. On your chart, they're saying R prime could mean either the carbon or the hydrogen. Right? So just make sure you're familiar with what your chart notation is. So we're saying, hey, the arene or the, we call that the aromatic group. So make sure you put that in your own notes. The arene, put underneath it aromatic. That could be all different hydrocarbons coming off those 6, or it could just be all H's. Doesn't matter. It's just interchangeable. Is that okay? And then X is very unique because it's the halogen group. Yes?
So is the R prime like on that the same as?
It isn't on there. Yeah, it's a little different. This has its own notation. So this is the one you're going to stick to right here. This is the one you'll have in your hands at all times. This is the one you're going to stick to. And you're like, well, why are you showing this? To confuse us? No. What I'm really trying to show you is that, in general, you're always safe to say R is just basically trying to represent like hydrocarbon chain or an H. That's you're safe to know right now. X always represents the halogen band. Okay?
On ours, it says R apostrophe is two different or identical groups. Can you elaborate on exactly what that means? Two different or identical?
Yeah. Because they're trying to say, look, if you did a ketone and you have a group that takes off over here, you know, this might be an ethyl group and this might be a propyl group. It's still a ketone. And all you need to know is if a ketone takes off with any kind of carbon on either side, you've got yourself a ketone. It can get crazy on either side. Right? Lots of different backbones. Millions upon millions of organic chemicals.
And just to be clear, the O on ours is representative of oxygen?
Yes.
Okay, just making sure.
Yeah, so
And S is sulfur.
yeah, but to be more specific, okay? Carbon and hydrogen's the only thing assumed.
Okay.
If I had another element off that periodic table, I would have to write it in there.
Right. Mhm.
So the fact that it's an O is literally saying it's oxygen.
Okay. Got it.
And by the way, no assumptions on any H's connected to that oxygen. I would not assume it. It would be writing. It would be written in there. Is that clear to everybody? Carbon's the only one that assumes a certain number of hydrogens based on 4 things attached. So good questions. All right, here we go. Let's get into naming this now that we kind of got a little bit of an introduction. You guys have this idea? Step 1, always find the longest chain. That's what you always do. So now look at this structure. This is straight, 1, 2, 3, 4, but this curve gets a longer chain. So that's the parent, the long chain. So 5 is the parent. You with me? So that's the key. Always find the long chain. How long can you string carbon before you run out of carbon? Longest number, that's the chain. And then this is a branch. And the branch group is called, on this one, anybody? Methyl. Thank you. Somebody get some confidence here. You guys got this. It's methyl, right? Now, where is that methyl attached? Because you have a few places it could be attached. Could I attach a methyl on the end? Trick question. Like it's here on there, but just pretend I pulled it and put it on the end. Would that be a branch? No, why?
It'd be part of the longest chain.
It'd be part of the new longer chain, and that would be the end of that story. So the only places it could be is here, right? Or both. I have 2 different positions, here and here. So now how do I designate what that means? You count. And the way you count is you count such that the branch is the lowest number. So if I count from this end, I go 1, 2, 3. The branch is off of 3. If I count from this end, I go 1, 2, 3. Branch is off 3. That's it. That's what it is. It's 3-methyl pentane. See how I did that? 3-methyl pentane. And that locks it down. As opposed to my other option is 2-methyl pentane. Those are the 2 variations of this that I could possibly make. And if I said 1-methyl pentane, as you just pointed out, that's not right because that just extends the chain. It's now hexane. Yep. That's the system.
Could you remind me how you got methyl?
Yeah.
Yes.
I understand, meth is
So,
one.
well, say it again.
Meth is
No,
one.
say, I understand
I understand.
meth is 1.
Meth is one. Yeah.
That's it. There's nothing I can elaborate. You nailed it. Meth
Yeah.
is 1. So every time I see a single carbon, it's going to be a methyl group.
Oh, is that okay?
Oh, that's it. And if it was
Okay.
2 carbons, I'd call it ethyl. If it was 3 carbons, I'd call it propyl.
And that's going back to adding the ol.
It's just, it's the YL means it's single bonded carbon side chain.
Okay,
Yep.
gotcha.
And the fact that the whole thing is single bonded, like the parent, I ended in ANE.
Okay.
So this is 2-methyl pentane. And those words all mean to me, it's all single bonded. And there's a branch with a single carbon branch on it.
Okay.
Okay? Now they counted that as 6, but let's just confirm, is that right? Work around here. 1, 2, 3, 4, 5, 6. Oh, I can't get it any longer, but be aware, I mean, try it different ways. Do you understand what I'm doing? Now, if I count it around this way, or I count it around that way, it really doesn't matter because I'm still getting an ethyl branch at 3, and also a methyl branch at 3. But the parent is, anybody out loud? Hexane. This is hexane. It's all single bonded, so it's hexane.
Okay.
And so what we do is we just throw in there 3-methyl, 3-ethyl, hexane. That's the name of this thing. And to be proper, you do it alphabetically. So here we go. This thing I don't know if I can quite fit it in here, but we'll try. 3. Now, whenever I put a number, I always put a dash, not me, but this is the notation. You always just put a dash before and after every number. So this is 3-ethyl, because alphabetically that comes before methyl. And I also have a branch of 3-methyl. And then all I do is hexane. There you go.
Is the reason you got ethyls because there's 2 on the top?
Yep. That's 3-ethyl, 3-methyl hexane. And just, this is cool about this. This doesn't really, it's neat how it catches varieties. If I numbered it like this, I would have got the exact same name. Right? Because it still has a 3-ethyl, 3-methyl hexane. Same thing. And those are important because you got to understand the molecule itself, like it takes into account the true piece of the molecule, right? I'm just going to show you kind of how this looks. This is hexane. 1, 2, 3, 4, 5, 6, 7, a little bit. I didn't put the methyl in there. I'm just dealing with the ethyls just to show you why it doesn't matter. Do you see the ethyl branch? If this is the main chain, it doesn't matter which one of those is doing the branching. It's the same molecule. So the name covers it. If you name in this manner, it covers both scenarios, right? There's no difference. And that's the secret to this. If you follow these rules, put the branch at the lowest number possible. In other words, if I start here and I go 1, 2, 3, 4 methyl, that's a higher number than starting here and go 1, 2, 3 methyl. So put the branch at the lowest number, and that tells you which way to number from. And that's it. And it will take care of any variations. The naming system, which is cool. Bunch of nerds figured that out. So hyphens to separate numbers, and commas to separate numbers if necessary. Forthcoming. You'll see what I mean by that. Don't worry about that yet.
You said start from the lowest. What was the word?
Yeah. So here we go. You ready? Do you see if I started counting from this side, then that branch would be at a 4? But if I count from this side, the branch is at a 2.
Oh,
That's it.
okay.
So when I number the parent, the secret is find the parent, number the parent.
Okay.
Number it in such a way that the branch is lowest.
Okay.
Okay, you guys, tell me what you think this should be then. One, is there a branch at one?
2
Go, okay, and then this is called ethyl or methyl?
methyl.
Okay, 2-methyl pentane.
Pentane?
Done. That's 2-methyl pentane. Good. Someone on this end, you guys ready? Try this one out. And again, it's kind of done for you, but let's just play the devil's advocate and go, well, what if I started numbering here? Where would that put the branches at? 4, and going here is 3, and the correct answer is go from the low number. Good? Okay, you guys ready? Down there. 3 what? 3 methyl. And then 3 ethyl. Yeah, I'm sorry, but you're right. 3 ethyl, 3 methyl. How do you name this pair? Hexane, yeah, that's it. Now this one, this is a good one because you might be tempted to call it 5 carbons, but if you wrap it, it becomes 6. So always look for the parent. And then why not count from this end? Because that puts the branches at 4. If I start here, it puts the branches at 3. Right? You guys want to try this? What do you think? 3 methyl. And then there's another branch. 3 methyl, right? And then the main branch is hexane. So now, how do we do this when we have a replicating branch? Right? So I'm going to show you that part. That's where the comma comes into play. Ready? That one is 3, 3 dimethyl hexane. So that's how you can take care of kind of having the replicates. Like if I had methyls all the way along, I could put as many methyls as I want in, In this case I have 2, so I'm going to go dimethyl. Where are they located? Both at 3s. 3, 3-dimethyl. And then I separate the numbers with a comma. That really is all the parts of the naming. It's a lot, but if you get it, you'll get it, right? It's very systematic, very systematic. Find the parent, make sure you number from the lowest. So here's one that wraps and gets all the way out to 7. Wait, I want to count from here. 1, 2, 3, 4, 5, 6. Okay, that's not going to help me. So here's the longest chain I've got. Why don't I number from this end?
Because it's not the lowest.
It's not going to get the branches at the lowest side. Number from here. So all together now, what do we got? Come on, these are branches at 2.
3, 3.
Yep, 2, 3. Dimethyl. 4. What's that branch? Ethyl. 2, 3 dimethyl, 4 ethyl. Then just name the parent. Heptane. Crazy, but that's it. And then this is the big one. And the only difference they did was this. Alphabetically, this comes before the methyl, so they put it in that order. You don't count the dis and tris as part of the alphabetization, but I probably wouldn't be flagging that. It's pretty. Yeah. Got it? Ooh, let's try and go in reverse. You guys ready? Now, to get you started, draw the parent. How many carbons should I draw?
2.
5. That's the parent. Draw 5. Then number. If you number from the left, you number from the right, you're both correct. It does not matter. Right? It's just kind of like this. You know, if it's sitting like this, you're going to go, oh, I'm going to number from the right. But if it's sitting like this, I mean, it rotates in space, I'm going to number from the left. I just number in such a way that I capture the branch at the lowest number. Follow? Okay, so try this. Again, my advice to you guys is start with the parent. Draw it out, 5, number it, and then as you come to these numbers, put your branches on there. Put a methyl at 2, put a methyl at 3, you're done. Here we go. How many carbons for pentane? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. What do I branch at 2?
No.
Methyl. Boom. What do I branch at 3? Why did you draw off to that? Why did I draw it down? Because it doesn't matter. Right? That does not matter. How these look, up, down, that doesn't matter. That's not anything you need to worry about right now. Make sense? Who's feeling brave they can come up here and do a 3-ethyl heptane down here on the board? I don't know if I should even let you guys get near this board because it's kind of got a mind of its own. Here, I have an idea. Okay, now it's kind of flip proof. Put the brakes on. Looks like having no board. There we go. That's it. All right. 3-ethyl heptane. Somebody brave out of this crowd. 3-ethyl heptane. Come on up. The nice thing is you're in it together. She's the brave one. You just don't leave her hanging. Don't let her make mistakes. Okay, you're all support. Don't let her just like. Okay, and then down on this end. I'll let you guys off the hook right now. But you guys, somebody come down on this end. Let's make this 4-tert-butyl heptane. That's tough. Somebody might need to look around and look at the tert-butyl notes. You guys have computers, so you can back up to remember that one slide that showed you the groups. Go find the tert-butyl group.
Is it this?
No.
On the 3 branch?
The chicken foot.
Yeah. Just go like to the right. Yeah, sure.
Oh yeah, nice. Oh yeah.
Don't judge me.
I like it. Cool. All right, you guys ready to come down on this end and do a 4-tert-butyl heptane? Somebody jump up. It's easy. What do you start with? What does heptane mean? Okay. You're elected. Go draw 7 carbons. You got that part. Now, the only criticism I have about this, it's correct 100%, but please get in this habit because that helps everybody. Number it up. Where should I number from, the left or the right?
Left.
Okay, good. That's going to help me because then that's going to make sense. 3, yeah, agreed. Make sense? Always number it that way. Oh, look, she even numbered for you. All right, yeah. All right, who's ready? Who's got the tert-butyl group? Have you guys looked back in your notes?
Trying to find it.
Yeah, that's cool.
Where is it?
Magical slide.
It was in today.
Here we go. I'll help us all do that. How about it? Whoa. There it is. So it's connecting like this. This is where it connects. So then just 1, 2, 3, and it connects in the middle carbon. Who's got that? What terp-butyl was it? Where was it? What carbon was the terp-butyl coming off of? Number 4?
Yes.
I'll get you started. Okay. Come on, you got this.
Well, how, looking at what it looks like.
Well, you're looking at it.
Is it
See
just
it?
two? Well, do we add CH3CCH?
No, you can just put a little line, right? Every one of those is just a line. Right? Remember, every carbon is just an end point, right? So I get there to that carbon. See, it's the end of the red line. I go to the left, I got how many carbons?
1.
1. Go to the right, I got 1. Go to the bottom, I got 1. Yeah, there you go. Perfect. And extra points for being brave. Thank you. No, seriously, that's a big deal. Guys tracking? I wouldn't know this is a carbon except there's a break in the line, so you're like, yeah, that's got to be a carbon. And if I count them out, 1, 2, 3, 4, that's where the butyl comes from. It's a terp-butyl. Perfect. It's about as complicated as it's going to get in here.
So do you count the center in the carbon too?
You count what?
Like the center where they all was it carbon?
Yeah, and only because there's a cross through it. Like when lines hit lines, that's always a carbon. When lines hit lines, that's always a carbon. Right? Because that's what, you know. See that in here. It's right here, right? Wherever lines hit lines, that's a carbon. Carbon, endpoint's carbon. Perfect. There's the first one. Here's yours. I like your 9 better, by the way. And there's the chicken foot. Chicken foot down, chicken foot up, doesn't matter. Easy enough. Good. Okay, we're going to go up one. You ready? Wow. Alkenes are hydrocarbons that can have carbon-carbon doubles. Alkynes have triples. Alcohols have OH. And alkyl halides have RX. Now the reason I put these all together, because these are the only groups we're going to learn the name on. Just to give you a little flavor and then we're done. That's it for naming. Just to kind of give you, you're already there. Like what you just did, that is the bedrock of organic naming. Okay, you've got it. Find the parent number to get the lowest amount on the chain. Go from there. Pretty straightforward. Now, same rules apply. Find the longest parent. Yep. But now, if you have an alkyl halide or an alcohol, you have to touch it. So the parent has to touch the alkyl halide or the alcohol to be the parent. If it's an alkene or an alkyne, the longest chain runs through it. So it gobbles up the double and the triple as part of the parent. Okay? So I'll just show you kind of a variation of what I would mean by that. Look, if I look at here and I got a pretty long chain going, but this takes off and it has a double on it, all of a sudden this takes over as the parent. The fact that it has an alkene or an alkyne means the parent has to run through that alkene or alkyne. Follow? Same idea. Hey, I have this beautiful long chain, and then all of a sudden this is an alcohol. Whoop. I've got to make this turn to get the alcohol included. The parent has to touch the alcohol. Not that it wouldn't have, but maybe if I said, and then somewhere along here, I branch off and get an alcohol. Now all of a sudden, this has to be part of the parent. So I go up here and hang a left to get the longest parent. Now that's the parent. And then the group is a what? What's the branch?
3.
Propyl. Yep. And then now we're going to number where the branches are, right? So this is now the parent. So should I start here, 1, 2, 3, or should I start here, 1, 2, 3?
Left.
Left or right?
Right.
Right, okay, good. Now once you got that, 1, 2, 3, 4, 5, 6. I have a 2-propyl hex, right? There's the 6 carbon. And then just a quick switch, hexanol, and I'm done. That's what that means. Okay, let's start with this. How do you name them? Now do you see this idea? I've got to capture the parent. So let's do the first one. You ready? What's the longest parent on this first one? 6, right? You see 6? 1, 2, 3, 4. No, 5. Sorry, can't count. Pent. Agreed? Now, if I start on this in numbering, I'd say, hey, the ene is sitting at 1, 2, 3, 4. But if I start here, it's number 1. Right? I'm going to put the number such that that alkene is right at the lowest number again. So I'm going to number from this side. I'm going to go, oh, 1 pentene. ENE flags it. Got it? If I started on this end, it would have been 1, 2, 3, 4 pentene. So I always, see how I'm keeping that rule? Try and keep the number low. Is that all right? Now, I didn't hear ane, so it's not all single bonds. I heard ene. Oh, there's a double in there. True? Now I have a triple bond. The naming changes to ine. How many carbons? So we've got to count them out. 1, 2, 3, 4, 5, 6 now, right? Count from the left or the right? Right, and it's 2 hex ine. And again, if I had the structure on my paper, I'd start numbering. It really helps when I number those up. Then I know that I put things at the low number. All right. So now here's this. See how we had to get the parent to capture that? Should I number from the left or from the right? Right, okay, 1, 2. That would be correct. If I started from the left, I go 1, 2, 3, 4. Okay, we're going to stay here, right? So it's going to be 2, and then if you count all these, how many carbons? 6. So it's 2 hexine, we know that. Agreed? But how do we account for this? Where's that branching off of? 3. There you go. 3 propyl, 2 hexine. Ene, sorry. I messed that one. Very systematic, very systematic. So the people who developed this are called the IUPAC, the International Union of Pure and Applied Chemistry. It sounds like a bunch of nerds, right? And they sit around and figure out these naming systems. I'm not interested in that job. Trust me, that's like, whatever. I'd just soon staple my tongue. No thank you. Right? But it does make sense, right? The system is very, very, it's very methodical. Count your longest parent. Make sure your branches or functional groups get the low number. Any branches get assigned a number where they branch, and away you go. Now, do you see how that the alcohol touches the parent? Right? And again, now we get a little bit of priority stuff going on. If I start from this end, this gets a 1, 2, 3. If I start from this end, it gets a 1, 2, 3, 4. Right? So what you do with this is you make sure the alcohol, this is unique. This is a priority system, so this will be the only one I throw in like this. It gets priority. It gets priority over all branches. So once again, my numbering, I say, I'm going to give the alcohol the lowest number, period. So that one gets priority. And by the way, when you look at your sheet, if you flip it, that's what that priority system's about. See how it's high to low priorities? We're not going to use it for all the functional groups, but this is what you do if you're naming an organic. You would go, oh, alcohol's above alkenes and alkyl halides and alkynes. So the presence of an alcohol says use it to determine your low number. So I don't have to worry about left and right here. I mean, as far as these branches, I just go, okay, I'm going to start here. That's going to give it a 3. Start here, it's a 4. 3 wins because it's an alcohol.
That's
Okay.
the same for alkyl halide.
And then look at where it sits on the alkyl halide is not so high in the priority list, right? In fact, it's very low. So no is the answer. Alkyl halides get just grouped in, whatever gets the lowest number. Most branches, lowest number, or alkyl halides. Great question. And we'll see that here in a minute. There you go.
How are we determining that it's run through or touched?
Well,
Like, is it just based on the?
so here's the OH is connected to a carbon.
Okay.
That carbon has to be on the parent. Can't be part of a branch. Or maybe let me reword it. The carbon it's touching is part of the parent, period. Okay, here we go. Now, you're just asked that question about the halogen, right? So this is kind of, not really that relevant, but you could say, hey, the only branch is the halogen. We'll just make sure you get it the low number. I'm not going to number from the left, I'm going to number from the right. Correct? And now what we do with these, the naming system is just different. It doesn't get anything named at the end like like the alcohols get OL attached at the end, right? These just say chloro. So we go, oh, 1, 2, 2 chloro. What's the parent's name? 1, 2, 3, 4, 5.
Penta.
Pentane, and it's all single bond, so it's 2-chloropentane. As opposed to putting it on the end, which I would call, if the chloro was just sitting here, I would say 1-chloropentane. And if the chloro's sitting here, I would say 3-chloropentane. And if the chloro's sitting here, be careful, 2-chloropentane, which is the same thing. Right? Remember, this is my halogen now, in the little fancy color. Being on this end is the same as being on this end. It's the same molecule.
Oh, I see.
So the low number rule captures that. Good. All right, you guys take a minute with these last two. See how we're going to do this. And again, you asked a very valid question. These don't have any more special priority over these. So you're
It's just alcohol.
it's just alcohol. And so these you go, okay, just whatever gives me the lowest branch, right? Whatever hits the low branch first. So this one I like though, because you got to be careful. Watch for your parent. Be careful who your parent is. That's what I would say. What does that mean? It's like my family. I have 3 brothers, Mike, Mark, my name is Joel. Huh. They were brown hair, and I'm blonde hair. Just pretend. So now when I say be careful who your parent is, I'm like, Mom, should I know something about the mailman? Oh no, I'm sorry, I'm just kidding. Okay, enough of that. That's inappropriate. But be careful who your parent is. Okay, what I mean by that, sorry, just to make the point, look for the longest chain. Don't get suckered in, right? Man, that guy's out of line. Whew, look at this thing. It's like a maze. would write it and then start numbering to make sure I'm confident where the chains are, like the longest chain. And I'm going to get this off, and you guys can work on these structures up here on the overhead. You guys got off the hook earlier, so you get the beast. We're going to have you work on this one down here, okay? This will be you guys' to work on. And the key is get up here and number out the parent, right? Number the parent. That's the key. All right? You guys been working hard over here, so we'll let you guys jump up and do the one we already have named. But just show me the numbering system. Will somebody drop up there and put a number on it? Oh, you look like you're wanting to do that. But you guys support her. I'll leave her hanging. All right? How about this group of 3? You guys, will you number that thing on the right? Somebody out of there?
Yeah, because the
Colors.
yeah, because
Kind of hard to see that there, isn't it?
Like the longest one would it be like 1, 2, 3, 4, 5, 6, 7,
Yeah.
instead of 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6.
Beautiful. That would make sense to put 2 chloropentane the way you have it, right? Good. By the way, when you guys go, now if you look online under this unit, you'll see the little handout that's it's got practice with answers. You can use that. It's just more of this stuff, and it's more of a walkthrough again. Find the longest parent. It'll help you with that. Oh, you're doing it. You're jumping in the big boy. Proud of you.
I'm going to try.
Okay. That's 7 going that way. Cool. Yeah, I agree then. Yeah, good call. Yep. Excellent. Right? Yeah, it's got to be. I love it. He's got that. Now who's ready to help him out with the other parts that are like, what are the groups then?
Oh, did you just want us to count it?
Yeah, no, that's what I wanted you to count. I wanted you to start by counting. Did you already name it?
Yeah.
Perfect.
We thought that
Where did you put it? The name?
We did it right up there.
Yeah, get up there and write it. Yeah, we're ready. You've done the hard part.
Okay, so
Now, somebody else help him out. He's got the numbering down ready for you. So now come up and put groups on it. We got what's hanging off of 3? It's hard to see on here, but that's a 3.
oh wait, no, 3. It's a hydrocarbon.
Yeah, and it's specifically 1 carbon, so you call it methylpropyl. That's 3 methyl. And then 4 is a special group, right? It's a propyl, but it's hooked in the middle, so we call it isopropyl. And then you nailed the number 5, that's the
Fluoride.
fluoro. Okay. Let's see it. How are we doing? Oh, good. We're early. You guys are doing great. Not even a break yet. Organic naming.
Oh,
Where's my eraser? So I need some space to work. Oh, here it is.
Worst head.
Nice. Then I go, oh wait, now the parent's 1, 2, 3, 4, 5, 6, 7, 8, 9, and I go, aha, it's 1, 2, 3. I can't count, it's 8. There you go. I'm now saying, oh, I've got 1 cyclohexyl octane. Parent is always the longest chain, whether it's in a circle or in a straight line. Now, this is unique. I'm just showing you this for a second. Anytime I see this, we know that, wait, that's a unique functional group. Remember? The 6 carbon with this alternating double single, then don't worry about the naming. You just call them, this is an aromatic group. Okay, and sometimes I'm going to we've got 3 words we've learned here. We learned arene group. You got it on your chart. You've heard aromatic. And then literally the ones that are all hydrogens, that molecule itself is called benzene. That's the name for that. So that's kind of 3 different names associated with that. Sorry about that, but it's a lot of things getting battered around there. The general arene group, though, could be this structure with lots of things substituted. Carbon chains, blah, blah, blah. That would be the arene group, or the aromatic. Benzene itself is literally carbon with hydrogens only. It's the benzene molecule. It's cancer-causing. It's a good solvent, but you have to be careful working with it.
And it's different because it has double bonds?
Yeah, well, it's just different because it's 6 with the alternating double. It's a very unique structure that's prevalent throughout organic chemistry. So I'm not going to start trying to go, oh, it's some sort of cycloalkane, right? I'm not going to go there. It's just like, oh, this is different. That's a functional group. That's an aromatic. Cool. Now this literally is cyclohexane. It's the same thing that's above it, just drawn with just easier. Exact same thing. And you'll see it different ways. Sometimes you see it drawn funny like that where the H's are up and down. That's going to show up with you guys with Sugar World. When we start talking about sugars, sometimes there's a reason for that. What do you call that? Cyclopentane. Because it looks like the pentagon. Yeah. The pentagon's a cyclopentane molecule. If you're nerdy and a chemist. I was like, what are you talking about? I don't know. With me? And again, I draw this as kind of a unique structure, but this will come when we get to biochemistry. Some of the sugars are just drawn this way. And that will make sense when we get there. We're not ready for that yet. Again, I already talked about this. It's apparent if it's the most carbons. If it's not, it's just a substituent, right? Same rules, just number substituents so they have low numbers. In other words, if I have different branches around here, this is hanging off here. I don't want to go right, I want to go left to get the numbers low, correct? And so now I'm going to go, and to be technically correct here, I would go, hey, wait a second, chloro's alphabetically before octo, right? So I'm going to be proper and go, that's the numbering direction. So now I'm going to call that 1-chloro, oh, sorry, I just broke my rules. There we go. There we go. It's a 4-carbon chain. It's shorter than my ring. So I go, okay, 1-chloro, 4-butyl cyclohexane. Same pattern, same pattern. Longest parent, number with the lowest substituents, and away you go. Okay, what do you want to call that? And by the way, you see that sometimes the methyls come in, sometimes they're just points. It doesn't matter, right? Like sometimes it's just an end. It would have mean the same thing, right? Just an end. Okay, what do you think? What is that group hanging out of there, off of that ring? Perfect. And then what do you call that ring? Cyclopent. I agree with that.
With 1 cyclo.
So you said it's 1 ethyl.
Yes.
Cyclopent. And how do you finish it to show it's all single bonded? Ane. So it's 1 ethyl cyclopentane.
So do you always just start at 1?
Yeah.
The first branch off, I can't
Yeah.
just say it's 2.
Yeah, that's correct. And by the way, if you said ethyl cyclopentane, everybody would assume that's hanging out in one spot. I mean, right? That thing rotates, so. Whoa. All right. That's a good one. Who's the parent? That's what I'm always wanting to ask. Who's your parent? Is it 5? Or is this a parent?
When you count the branches, do you count like the carbon that's touching the pentagon? Would that be?
That's a great question. In other words, ooh, that didn't help at all, did it? I think I understand what you're saying. Do I count that carbon as part of this? Is that what you're
Right.
asking?
Like, is that
And the
one,
answer
two?
is no. That's all by itself because it's part of the cyclic system, so that's the first
That's
one.
1, 2, okay.
Yep. So, next question. Is this the parent on the left or is the cycle the parent?
On the left.
The left. Okay, cool. So now when I go to number, would I number 1, 2, 3, or 1 on the right?
On the left.
Okay, cool. So now we can start numbering. You know, we got how many methyl groups attached? 2. So 3, 4 dimethyl and 1 cyclopentyl. And there you go.
How come you wouldn't number it from the other direction?
Yeah, good question. If I number, so that had a branch at 1 because it's got a cyclopentyl branch at 1. If I number from here, the very first branch I see is at 3. And that's how you answer. You always number
You
such.
wouldn't consider 1 to be a branch because it's just has the hydrogen, no carbon?
Oh, this thing here? Yeah, this is, I mean, these are assumed. If I'd have drawn it this way, it would have been the same thing. I'm just, that's not a branch. Does it help?
Mhm.
Yeah. And are you guys following her question? This is an important question. Sometimes these get popped in there for different reasons. Like the program I used to write this. By the way, if you guys have a PC-based computer, this is free. This software drawing program is free, and it's actually creepy powerful, like what it can do. So you can just draw these structures yourself, like you just basically dot, 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 and it just draws the structures, very simple. But every once in a while, instead of putting just an inline, it'll put a CH3, just fill it in for you. And just keep in mind, that's not a branching, that's a hydrocarbon chain. That was a good point you made. Not magnetic, just so you know.
How is it? Sorry, do you mind going back?
Yeah, I don't mind at all.
How does the cyclopentyl is that 1 if the 1 starts off?
This is 1, and the branch on 1 is a cyclopentyl group.
With a, okay.
So it's called 1 cyclopentyl. Two, 3, 4, 3, 4 dimethyl, and then what's the chain called? Hexane.
But isn't a cyclopentyl just the structure itself, the 5 structure itself, not with the another?
Yeah, but see, it's a branch off of this thing. It's a branch off the hexane.
Okay.
The rings are considered branches if they're not the longest carbon chain. They're considered a branch. And I could have put it different places. That could have branched off somewhere else. Right? I could be somewhere in the middle and go like this. Totally different molecule if I went down here and had a cyclopentyl branch. Then in that case I go 1, 2, 3 cyclopentyl, 1, 2, 3, 4, 5. Oh, that's a tie. Trying not to do that. It's confusing, right? 3 cyclopentyl hexane. Make sense? Cool. All right. We'll get ready to practice when you get back on these. Take a break though. Appreciate you guys working so hard. Get over here. And then you guys, will you take care of the other bottom right structure? And that will go over here. So Let's go, people. Hop up and start drawing and numbering and naming. Yay! I'm gonna take a break. Nice work. See you when I get back. Enjoy. Have fun. I've got as many carbons as I can stick on there. Once I start putting a double or triple on, I've lost a hydrogen every time I put one on. Does it? Do you guys understand what I mean by that? Let me just show you. I'm going to do a propane structure, right? So you can understand. Let's focus on the middle carbon. Okay? Just the middle carbon. How many hydrogens are attached here? Two. And that's the most I can put on there, correct? And have it in the center. So we call that saturated with hydrogen. Once I get here, how many hydrogens are attached? One. Once I get here, how many hydrogens are attached? None. It's unsaturated. So when it comes to alkenes, they're called unsaturated. And I am leading you towards the biochemical world when you start talking about polyunsaturated and saturated fats. That's literally what they mean. When I hear about an unsaturated fat, there's a double or triple bond in there. And to be specific, it's a double bond. Okay? And I'll show you more with that when we get there, but I'm just going to get you introduced a little bit. So here we go. Does you follow? Is everybody tracking with the idea of saturated versus unsaturated? You can do it one of two ways. You can count hydrogen, but maybe it's just simpler to say doubles and triples are unsaturated, singles are saturated. That's the simple way to kind of keep track of it. Now we're going to focus on the alkene. That's the important thing. Now, true enough, the triple bond straightens out the molecule, so it makes it straight as an arrow. And that's going to mean more to you guys later. We haven't done much with this, but I'm going to show you some important stuff about state and rate. Liquid, solid, gas, and how fast it acts based on shape. Okay? But here's what you know. Look, this thing is like that. I've shown you a lot of these kind of tetrahedral shapes, but once you get this, these are all 120s. It's flat. Literally, this is the correct geometry as drawn. Right? Like if I make that double bond, and then I put the other groups on it, it flattens out. Like it's, all these atoms are in the same plane. You see it? Okay? So it is as drawn. These are a little harder to do because some of these are coming in and out. So once it becomes single, right, those things are kind of sticking out. They're not in one plane anymore, right? So that's going to be important for stuff we do here in a minute. But I want to just show you this on the alkene, and then we'll be done for the day. At the end of each double bond, we call those ends, but these are important sides. Okay, so now I'm going to attach something to these doubles and be very specific. All right, so we'll put these on there. All right, there we go. So on the side, I could put things on the same side. Like that. We call that cis. Or I could put it like this and call it trans.
Wouldn't it be the same thing?
And it looks the same, but it isn't though. Look at these, they're very far apart from each other, right? And actually, as this continues on, it kind of looks like a straight chain. It'll just keep going. Like if I had a series of these in the chain, they'd be straight like this. The minute I start to do this, though, with them, here, and I keep the chain going, it'll keep doing that and it'll wrap into a circle.
Okay.
So trans fats actually start to circle into a loop, a helix, and then, cis fats. See how they're cis? These start to loop around on themselves, but if you have it trans, they'll lay flat like a chain. So, to begin with, identifying cis versus trans. So, if I was being very specific, I would say it's butene. You guys agree with that? It's number 2 carbon. 2-butene. But I'm going to be very specific, what we call stereochemistry. They're cis. The carbons are coming off on the same side. Who would catch this little change up if I did like this? And put the carbons on the ends. Who would catch the trick? Who's the parent now? How many carbons in the parent? 3. It's no longer butene. It's pentene. And in fact, it's, if I was numbering it, right? Number from the left or the right? Left. It's 2-methyl 1. Totally different than these. That's a butene. In this case, that's a cis-butene. There's a trans-butene. You with me? So we're going to learn that. That's called stereochemistry. It's very relevant to body stuff that goes on in biochemistry, so I just want to get you introduced. Those are called stereoisomers. They're the same chemical formula. Like if I gave you and I said butene, everybody go, there's 4 carbons, right? If I said 2-butene, I could call both of these 2-butene. Agreed? Everybody with me? They're both 2-butene. So the only way that shows the stereochemistry is the cis and trans, and that's going to be relevant for some stuff we study down the road. Okay? Now, I'm going to just give you the first introduction. So what? Let me give you the first so what, and then you can get out of here, because you only got a minute. So what? All right. That atom doesn't necessarily like that because it has electrons on it. You with me? So energetically, like the energy to make it, which do you think's harder to make? Which kind of puts them close. They're fighting brothers. You understand that. They don't like each other. Do you think they want to be on the same side of the table or opposite side of the table? That's correct. And this is lower energy form. So trans is lower energy than cis. I would literally write that in my notes. What do I know? Cis, higher energy. It can start to loop. Trans, lower energy. It's a straight chain. All of that will make more sense as I keep building this class. You ready to get out of here? Do you see how this would be good examples for you to look at? These are 2 pentenes. Can everybody look and see that that's trans? Same side. Same side of the double. Do you see them? Same side. And if it helps, look at the hydrogens. They're also on the same side. We call that cis. Same side. If you see them on opposite sides, trans. All right. More examples, but that's it. Into stuff, more practice. This will be good for you guys. You've got a boatload of slides that just have more examples. Like if you want to run through these on your own to just do some practice naming, this would be great quiz practice. I think I got up to like 50 of these, just extra practice. Woo! All about naming. Can anybody help me kind of get going on that? In fact, we just had an alkene on the board. here's one, right? So I wasn't very true to how you could draw it, but if I was being careful with how it's drawn, I could show you one that goes where the branches leave on both sides, or I could show you where the branches leave across the molecule. Are you guys kind of seeing that visual? And that's because double bonds don't rotate, so they're fixed. So if it's a molecule and you have arms that are like this, it's a lot different than if you have a molecule. So here's this double bond right here. So there's a difference between a molecule that looks like this and a molecule that looks like this. If it's fixed, like it doesn't twist, right? This is totally different than this. Do you guys know which is which when you see these? Okay, which one is this? This is cis and this is trans. So now when you start hearing trans fats and stuff, that literally is what's in there. There is literally and yeah, so this probably has cis fats in it. Okay, this is just vegetable oil, but it has cis fats in it. Okay? So we need to get that down. Now with that in mind, could we draw, we're going to get very detailed here, we're going to draw the cis and trans isomers of 2-hexene because it has all sorts of pieces and I want you to be able to do. If you see hexene, what are you thinking? How many carbons? I heard it over there. It's quiet, but 6. Okay, cool. And what does ene mean when you hear that? Double bond. All right, you're on your way. And where is that double bond placed in the 6-carbon chain? Carbon number 1, 2, 3, 4, 5? 2. All right. So what we're going to do is we're going to try and get that put together, and then we're going to make sure we put one in the cis form and one in the trans form. All right? So we're going to let, we're just going to cut you right down the middle. You guys can just team this up. You guys are off to this board doing the cis of this, and you guys are off to this board doing the trans of that. And we'll see what we can put together. And everybody should be able to do this. 6 carbons, and it'll take a minute. Take a minute. You might have to redraw it to get it where you like it. But do with that line bond drawing. And I saw some. Yep, so you're on your way to cis, or the trans, actually. That's the easy one to do. That's a trans. So now the cis is just a little trickier. Everything is the same. Well, where would you put the double bond? We'll put numbers on it. That helps. That holds. There you go. As it sits, the way you drew it is that trans. So that's the start. Now if you can do the cis. Then we'll get moving on this. Do you want to put that on the board for us? Okay, here's going. Yeah, you can get your trans hexene up and put the numbers on them. And you guys, it helps if you draw them and put numbers on them. That way you put things where they belong, right?
Go ahead.
How we doing?
No, I can do them.
Well, you have the cis going, right? Yeah, so this is the net. Now this, what would you call this one? That's the same side, right? Oh, I see what you said. You did it with the H's. You're close because you lost a carbon when you did it this way because it's supposed to be carbon number 2 where the double bond is. That's a hydrogen. You counted it as a carbon.
Okay.
So you're almost there. You're close. So let me get you started. I mean, this is pretty extreme the way it's bent, but do you guys see how it's that these are on opposite sides and they're around the trans bond? Does that make sense? So, you know, it's 1, 2, 3. See how they're on opposite sides? So I'm going 1, 2, 3, 4, 5, 6. So I made sure it was hexene and it's on the 2. And then this is trans, right? So now how would I fix it to make it cis? Yeah, we just get, you can move the whole thing or just move this little arm. What should I do with the arm? Put it down. So just redraw it and then just erase it, put it down, and you've got it. Then you have a cis. There you go. Is that? It'll take you a minute, but once you get used to doing these. So I'm going to do that one over here, right? So now I'm going to just do, I'll just do the same thing. 1, 2, 3, 4, 5, 6. That's trans, right? Because they're on opposite sides. 2, 3, 4, 5, 6. I hope everybody's going, this is 2-hexene. I'm fine with that. Is everybody okay with that? 2-hexene, that's A-okay? The 2 is where the double bond shows up, and hexene indicates there's 6 carbons. Okay? Cis means, trans means they're opposite, so this is like this. They transverse, they're on opposite sides of the double bond. Okay? So now I go over here, and I want to make it cis, so I just do the same thing. I'm just going to replicate this piece, and then I just need to go to the same side, and that's it. Now they're coming off the same side. You with me? So when you start looking at them, and so we don't usually go to the trouble of drawing that, right? We don't go to the trouble of making it accurate in 3 dimensions. But if I am asking about cis and trans, you've got to realize I have to draw it correctly. And if I was being real meticulous, and I'm pretty close, these are all 120. They're all the same angle. The H is coming off like this. These are all the same. You don't have to be that meticulous for yourself. You'll be looking at pictures and asking yourself which is which. Okay? So that's where we ended. And I said a couple things. Which one's the higher energy? Which one's higher energy when it's being made? It takes more energy. Which one? So cis or trans. So, and the way to think about it is those arms they have electrons on them, right? So they don't like each other. So do they want to be like this, or do they want to be like this if they don't like each other? Trans, right? That's lower energy. So cis is higher energy. So that has biochemical implications. That's why I'm going through this trouble of telling you this. So I have them opposite in energy. That's low energy. That's high energy. All right. Just kind of get you started. We'll come back and visit some more.